Hi everyone again. We are happy to welcome you on our GlobalLogic on-air webinar. All your questions, please write in a Q&A session, which you can find in the panel below, and our speaker Igor will answer them in the end. Now I'm passing the word to Igor. Igor, please.
Thanks, Alexandra. Hi, everyone. Nice to see you all today. I hope you are all healthy during this pandemic situation. It is kind of stress for everyone, but let's just be optimistic about it and stay healthy. So let me just hit the button for presentation. Start presenting. Okay, I hope you can see my screen properly now. And let's start with just a couple of words about myself for self-introduction. As you probably know, my name is Igor Kolosov. I'm consultant at GlobalLogic Ukraine, Kharkiv location. I usually play roles of automation architect or performance engineering architect on my projects. And I'm really passionate about different fresh technologies, state-of-the-art technologies, interesting and new approaches, and I like to share my experience and collaborate with other professionals. So usually I pick kind of rare topics to highlight because it's most interesting for me and probably most challenging. That's why it's interesting. And one of such topics is analysis of architecture diagrams. Probably this topic today is mostly oriented for quality assurance engineers, test engineers, but others may find it useful too. Maybe you will observe a couple of new tricks. I don't know. That's all up to you. And why this topic is highlighted today? Just a couple of words about that. The idea of this topic was born in the past during some onboarding stage on one of my projects. So I've joined a team which developed a project for maybe half a year, and I was really surprised about level of system understanding across quality assurance engineers. They just focused on their direct responsibilities and told me something like, oh, I'm following black box approach. I shouldn't care a lot about architecture. And this was a little bit surprising for me because, you know, in the modern world, if you are developing complex product for some period of time, you will always interact with first-line developers, and it's not clear black box technique anymore. So probably you will face clean black box only when you work with third-party vendors. When specification is really light, there is no knowledge about the system at all, etc. So black box is not a panacea at all. So why is it bad? Why it lacks test coverage? What's wrong with it? Actually, test cases are a little bit challenging to design without proper vision of the system, without precise functional specifications, right? You can miss something. And also you can miss some critical and maybe tricky inputs if you will follow black box technique. Also, it is also challenging to identify all possible inputs in your limited timeline. So as a result, your test case creation may be slow and painful, and there are some chances of having unidentified paths during the testing process. Also, there is a high probability that you will create some duplicate scenarios covering something already tested by the developer. Maybe there are some interesting integration tests. You just don't know nothing about that. And you actually can never be sure about your test coverage percentage, how much of the system under test has been tested. So this technique is okay. It can be used as a part of your test approach, but it is not definitely an answer why you don't understand your background and focusing just on a single component or just some UI or just some client, etc. It is always better for your test design approach to know something about the system, right? Your testing will be more effective. So here I've highlighted some benefits of visualization of architecture for test engineers. So in general, it will definitely speed up understanding of the system and its context. It will improve your collaboration with other team members, and it will develop kind of unified glossary across team members, right? It will unify vision of the system across team members. And also such thing as architecture diagram really helps to represent or present complex things in a relatively simple way. So it's kind of visual pseudo language, from my understanding, right? Also, it helps to refine your architecture. Maybe you will perform some architectural review, which will help your architect to build it better. Maybe you will provide some valuable feedback, etc. Usually architecture is developed as a general concept starting the project, but it can be adjusted. It can be slight adjustment or maybe major adjustment during development life cycle, but it probably will change a little bit, especially if you are following agile approach during development, right? So nice thing to add here will be help with sufficient test coverage. Architecture visualization helps you to create effective and precise tests, which will cover major parts of your system, right? And also, if you are kind of a security tester or performance tester, you will probably spot some major system weakness or maybe even huge bottleneck just observing the architecture diagram. So it is also useful for automation engineers, for performance engineers, for security testers, not only for manual test engineers, right? It helps all test engineers. Also, it is some kind of tool or maybe instrument which helps you to target and ask the right questions to the right person, to proper contact, right? You see something that is non-covered, you will definitely want to ask some question, and architecture diagram will stimulate you to ask right questions. Let's imagine common situation. You will start onboarding on some new project. Let's imagine kind of chaotic analysis. You see this diagram for the first time. Solution architect or software architect will start presenting you something. He will share kind of presentation across team members and perform some local presentation. Usually, it is common situation that not everyone are good presenters. Presentation skills is complicated thing, and it definitely require some skill development. Yeah, in perfect situation, you will face a person which developed technical skills and soft skills on the same level, but it's kind of a perfect situation, not so realistic. So that's why presentation stage can be not so effective as it can be. And you will end up in such situation when you will start hearing some kind of white noise or mumbling after maybe 5 or 10 minutes, especially if material is complex enough, right? And usually you will distract your attention to something else. You will think something like, whatever, I'll just wait for some coverage letter afterwards and check some attachment, and you will start checking your social network accounts, some messages, YouTube videos secretly, and at the same time you will try to mimic some professional mimics, right? So you will make some kind of serious face at the same time. As you understand, it's not so effective as it can be, but it's reality. It's common situation. Then, in a couple of days, you will start analyze your attachment, your presentation, how it usually is performed. You open diagram, stare at the monitor a little bit, zoom, look here, there. You try to read some labels, something distracts you, you are distracted by, I don't know, your cat, your dog, your wife, your children. It's not so effective at this moment already. And you don't have any approach here, right? You repeat this chaotically several times, and as a result, your memorization rate is relatively low. You will memorize kind of maybe 10% of overall information, which can be delivered to your brain directly from architecture and architecture analysis, and actually by proper questions which you will develop during this stage. What's wrong with this approach? It's not efficient at all, right? So you will waste huge amount of time. You will memorize relatively low amount of information, especially if your diagram is complex enough. You will probably forget majority of this information in a half year or maybe in a month. And as a result, your vision of the system is completely unclear. It's blurred, right? So as a result, just on the start of the project, you will have unstructured or missing inputs for your test coverage. You will definitely miss something interesting or maybe valuable, and you will completely fail with such approach on really complex diagram. I'll demonstrate this a little bit later. Here we have kind of example, right? Let's take a look on it for several seconds. You know, for me, it looks like a Death Star. It's microservice architecture of AWS, Amazon microservices, and it contains like thousands of different microservices with different purposes, which are connected by thousands of different links, connectors, data storages, etc. It's kind of extremely complex diagram, right? And if you are not a Luke Skywalker, I'm not, so you will probably spend not days but even weeks just trying to figure out how this system works on a general level, if you will not focus just on some single component, right? If you will try to observe the big picture here. So this chaotic approach, it will definitely fail, right? But why? I've tried to write down some most obvious root causes for such issues during analysis. Why do we fail? What's wrong with chaotic approach? Usually, you will analyze diagram ineffectively due to some gaps in your background knowledge, right? So you see something unfamiliar, you don't know what is that, probably you will Google something or just postpone this and it will be forgotten sometime. Also, practice with analysis is a good thing, and if you have not enough practical experience, you will definitely analyze diagrams ineffectively, right? Also, if you are not following any process, you will definitely do this in a worse way than following some kind of predefined process, right? Moving forward, if you are not familiar with kind of your visual language, visual representation, pictograms, arrows, marks, you will definitely don't understand what's going on your diagram, right? And high complexity is also risk factor here. You will definitely spend more time on high complexity diagrams, or you will struggle with analysis. Maybe complexity is too high for you, right? And time factor is also really important. Maybe you are Russian or you have not enough time for this activity. Maybe something will distract you, so procrastination is also important root cause of failures during analysis. And you know, fear of the unknown is kind of human quality which is applicable for everyone, right? It's kind of internal mechanism of our brain, right? It goes from maybe Stone Age. So it is applicable to diagram analysis too. You see something big, something unfamiliar, something strange, and probably something scary for you. You think something, oh, I'll spend days analyzing this, or okay, I've spent 20 minutes and I don't understand anything. Let's just postpone this. You probably can experience some focusing issues. So you will stare at some component, not seeing the big picture, do this chaotically, etc. And the absence of clear goal is also important root cause of diagram analysis failures. You should know what are you doing and for what purpose actually. I've defined some root causes and tried to find some unified approach which will help to do this a little bit more efficient. For this approach, I've tried to analyze our brain processing a little bit. As you maybe know or not, there are two ways of processing, most common ways of processing information by your brain. And these processing names are probably familiar to you because many of approaches across information technology industry are built around these internal brain mechanisms. Now I'm saying about top-down information processing and bottom-up information processing. You may find it familiar as something from business analysis, as something from design analysis or decomposition or estimation, etc. It's kind of general concept which helps your brain. And let's try to highlight this, right? So with top-down approach, you usually take something big, trying to observe it as a system, and then you decompose it into smaller chunks, into smaller objects, into smaller concepts or ideas. So as a result, you decompose big picture into kind of set of tiny details, right? This concept is synonymic to decomposition. And also we have bottom-up information processing approach, which works in controversial manner, right? So vice versa, you will start from bottom, from your atomic objects, concepts, ideas, and you will stick them together somehow inside your brain, inside your imagination, and you will have a kind of complete system as a result. What approach will fit such activity as diagram analysis better? From my understanding, top-down approach will work better because it is always complex to start from something atomic for huge and complex diagram without understanding general concept, without understanding the big picture. That's why I've followed a top-down approach and tried to create kind of checklist which will optimize initial analysis. Let's try to highlight this. This algorithm is relatively simple and fast. It will help during time-limited activities such as pre-sales, or maybe you will have kind of tight deadline and you will need to collect together as much information as possible. So to start with, we should set our goal. What are we going to target? What are we going to aim for? Are we doing kind of initial analysis? Are we doing kind of review? What are we going to do, right? What is our goal? Without goal, it is always too hard to do something, right? You are not driven by anything. Then we will try to qualify big picture. As you remember, we are starting with something big and then decompose it. And at this step, we will definitely be able to define diagram type. Is it software architecture diagram? Is it infrastructural diagram? Is it solution architecture diagram? Is it something UML based, like component diagram or class diagram, it is useful information already for your further analysis, right? Short remark here for test engineers, probably there are two types of most valuable diagram inputs and diagram types. It's definitely solution architecture diagram, which will help you to understand system, to collect some system vision, to understand connections between system parts, and actually to observe your workflow, the purpose of the system, etc. And probably the second most useful diagram type is infrastructure diagram, especially if you are going to build some test environment by yourself. It is kind of a common situation when you will have no DevOps, dedicated DevOps engineer on your project. So in this case, infrastructure diagram will be extremely useful for you. Different types of software architecture diagrams probably dive too much under the hood for your regular usage, for your regular understanding. But in rare cases, rare situations, you can also need them. So for example, if you are a performance engineer and you are trying to run some client-side performance analysis, this kind of diagram will be useful for you. Okay, that's all for short remark. It wasn't too short, actually. Let's go forward. At this point, you also can assess or qualify relative complexity of the system, right? Is it simple? Is it complex, right? You will probably adjust a little bit your approach based on that information. Also, you will be able to observe or to define your business domain, which is extremely useful. This information will affect your tests. You will be able to collect lots of details just knowing your domain, just reading something about your domain, about your business. And also at this stage, we will be able to define the general purpose of your system. Moreover, at the beginning, you will be able probably to define architecture style. Is it microservice based architecture? Is it entire approach? Is it something related to big data? I don't know. You will be able to observe this and define architecture style. Let's decompose it a little bit further. So moving down, you will be able to define some key layers of your system, right? Some key groups of your components, which are grouped by purpose, which is defined by your architecture style, right? So for example, for entire application, you will be able to find some presentation tier, data processing tier, logic tier, etc. It's kind of relatively easy step. And it is always good to know how your end user or some third-party system will interact with your server or maybe your system, your infrastructure. You will be able to observe clients. You will be able to observe some public access points as API or something else, some connectors. it will be extremely useful for your test coverage. At this point, probably you will be able to figure out some attack vectors or some load generation vectors if you are security tester or if you are performance engineer. If you are manual test engineer or automation engineer, you also will understand the scale of your coverage at this point, which types of tests or functional tests you will apply to the system, and where actually. Also, moving forward, probably you will be able to define technical stack just observing your diagram, just observing your components, right? Nowadays, modern icon sets for diagrams highlight such things extremely in an extreme easy way, actually. So, for example, you will observe SQL server diagram, and you will know that it works on SQL, right? So it is purposed for SQL, and it is database, actually. So moving forward, you can try to observe some groups of your components, or maybe group them somehow by yourself, by your imagination, if your diagram lacks such information. So imagination is always useful during any analysis activity. Also, you will be able to define roles of your components and assess them in a more detailed way. Moving down, you probably will try to define key data types of your system. And the extremely important step here is to follow, or maybe to define for yourself, some critical usage scenarios, some critical usage flows for your system, maybe kind of a critical path, right? Just observing the arrows on your diagram in a proper way. Maybe you will be able to define some sizes or amounts. It can be noted on your diagram somehow. It depends on diagram, right? So it is also very useful input for your test data planning, for your test coverage. And if you are a performance engineer, extremely important information for you will be system extensibility or scalability. Solution architecture diagram or infrastructure diagram will probably give you such a context. And as a result, you will probably come up with a kind of question list for further investigation, which is really good thing for you. Moving forward a little bit to general context, I would like to highlight other basic inputs for good system understanding, which are helpful in general for any system onboarding or initial system analysis, etc. So probably you will try to identify your audience. This step is extremely useful for performance engineers, and it is helpful for other test engineers in order to build better test coverage. Such inputs as typical user behavior, typical user profile, user roles, user groups will affect your test coverage significantly. So it is a good idea to collect such information at the beginning if it is available, right? Just ask the question. Maybe it is available, or you can try to imagine your end user by yourself, right? Just assuming kind of image or profile of your end user just from your domain knowledge, right? You know, business domain and you know, business purpose. So you can assume kind of portrait of your end user. Also, it is useful to collect all available information about your business domain specifics. Maybe there are some specific standards, or I don't know, it is a good idea to take a look at competitors to other systems. It will give you more context about your further project. And if we will try to, not you, but maybe your team will try to integrate your system with something from third party, right? It is extremely useful info to start with. So integration matters. It will affect your coverage. You will probably want to cover such integration points with third-party systems, or maybe even emulate such third-party systems. At least you should be able to somehow define approach for such cases. And going forward, always helpful to identify key use cases of the system from the start. Not really detailed or fully detailed scenarios, but at least some key usage scenarios, some key use cases, right? It is a good idea to ask about existence of non-functional requirements, even if you are not performance engineer, and check existence of system level agreements. Also, it is a good idea to understand which security measures system will incorporate or implement. Maybe this information is already known, right? So your solution architect probably will have some ideas about future security measures. Also, good idea to think or ask or Google about potential domain regulations or protocols or standards. Especially, it is extremely useful question for healthcare domain. There are lots of regulating standards there, and it is a good idea to think about something unusual which you may find useful for your testing. So, for example, some unusual or custom tools or emulators, probably you will be able to estimate this, or maybe to assess this even at the starting point, just observing the diagram. So you see some unfamiliar third-party system protocol, you probably should somehow simulate this input, maybe, right? Why not? It is a good idea to think about this at the start. And moving forward, I've tried to optimize a little bit this approach, speed up things a little bit, and try to find maybe different factors which will help you to perform this analysis faster, right? So, of course, if you are familiar with different diagram types, your brain will build up some cognitive connections, some memory connections, neural connections, especially if you are using your imaginary during analysis. So that's why I've highlighted imagination previously, right? So imagination helps you to build proper neural connections and connect your knowledge with your real-time perception system, and connect you with memory, right? You end up with kind of internal system for analysis of your diagram, right? So also it is really useful to get familiar with different architecture styles, so you will be able to spot such information much faster with some practice. You will be able to spot some specifics of each architecture style, and it is a good idea to keep an eye on up-to-date diagram notations and icon sets. You know, this type of input isn't so easy to follow, because for up-to-date knowledge, you should take a look from time to time at architecture centers of major cloud providers. Keep an eye on modern icon sets and such tools as Lucidchart or Visio. But if you are able to do this, it's useful and it will speed up your process. Also, good idea to build something on your own. Try to build at least simple diagram to understand the process of creation, vision, I don't know, some patterns which appear inside your brain during architectural creation. And this knowledge will be definitely addressed later when you will try to analyze diagram which was created by someone else, right? It is extremely useful experience. Yeah, I know it will take some time, maybe, I don't know, evening or several hours to build your first simple diagram, but it is extremely useful and will speed up you later. As for me, I always try to create some kind of notes during any analytical activity, and diagram analysis is not an exception here. So you will stimulate different types of your perception just writing down some notes. You will memorize things effectively. You will refine your questions. Notes are extremely useful, and good idea to always write down your questions, because you will forget something, or maybe you will somehow formalize your question when you will write down it. It's useful, and if you will follow the same process each time, it will definitely become faster and faster, right, over time. Practice is a key here, so more practice will lead you to more speed. And as I've highlighted previously, imagination is a good instrument for your brain, for your understanding. And also it is a good idea to have some kind of overview, not only of your current business domain, but some general understanding of specifics of different business domains, such as telecom or maybe retail, healthcare, etc. At least on some basic level. It's a huge investment into your background knowledge. Here I've highlighted a set of useful links which will help you to perform such activities better. As you can see, there are links for UML tutorials, lots of user-friendly information about general information about architecture and system design here. Also links for major architecture centers, modern architecture centers such as Azure, AWS, or Google Cloud. They were extremely useful, at least for me. Probably these links may help you too, so why not? Let's try. Moving forward, I would like to perform kind of real-time example of activity following our simple checklist. Just take a look at this diagram for a second, and I'll drink some water in between. Okay, so let's take a look at simple XML file. Actually, I've transitioned this kind of checklist into Excel file. It's not like something you should follow, but it is something that I usually do. For demo purposes, I will use just marks, but usually during analysis, I write down some comments for each step, a list of questions, a list of open questions, which will help me with further collaboration with the team, maybe with our solution architect. Okay, let's try to define our goal. At this point, for demo purposes, we will follow initial analysis, right? So maybe for onboarding purpose. If we will talk about review, review is relatively easy because you can find lots of predefined huge checklists over the internet for detailed architecture review. But you will not find too much information about our current topic, right? So probably for review, you should follow some huge checklist. It will consume much more time, of course, and you should assess such characteristics of your system, of your design, as consistency, testability, etc. So it's like kind of a different topic. Today we are focusing on initial diagram analysis, so it will be our goal today, right? So we have our goal. Let's mark it as successful. Let's try to qualify the big picture here, right? Let's at least define diagram type. As for me, it looks familiar, right? From my understanding, this diagram is a solution architecture diagram, right? It highlights your system in kind of widespread vision here, right? So it doesn't have too much specifics about details. It doesn't show you some layers or some details about your some kind of atomic application, right? Here we can observe big picture of the whole system without too much details and without too much information about infrastructure. So this is not probably infrastructure diagram. We do not have too much information about security groups here, network settings, or I don't know, other stuff which is related to infrastructure diagram. So it's solution architecture diagram, right? Let's mark as a success. Not here, but here. And let's assess relative complexity. As for me, this diagram looks like something simple, right? Previously, we have observed huge architecture diagram for Amazon microservices. It was like 1,000 times more complex. That's why, in my understanding, it is like relatively simple diagram, so we shouldn't it shouldn't take too much time to analyze it. Okay, let's mark success here, and let's try to define business domain. So as you can see, diagram name already have some useful information about your business domain. It is e-commerce solution, right? So probably it is something related to retail business domain. Also, as you can see, we have kind of customer mark here. It is end user, so it will probably use some services of the system or buy something, spend his or her money here. And there are some marks related to orders and products here. So probably it is something related to direct sales. Maybe it is kind of application for or website for web shop or something like that. Okay, mark here, and following this step, we also were able to define some purpose of the system, right? It will perform some sales activities, right? Customer will be able to observe some product images, to place some orders. Someone will be probably able to process these orders. There are some products, so the purpose of our system is probably sell something. I don't know what, but probably sell something. Let's mark it at least basic. At this point, probably I'll note some kind of additional questions just for myself here if I do not have too much details about domains, right? Let's try to define architecture style. It has kind of platform as a service components here, right? We did definitely have some data related components here, right? So we are processing some logic here, and there are some blob storages for product images. So as you can see, there are some clients. So I could assume that it is atomic case of entire architectural style, and it is something like 3-tier, right? We have presentation layer with which is represented by browsers. We have some logic layer here, and we have some data layer here. So it's probably entire and actually 3-tier. Yeah. Other any highlighted system layers here? Yeah, we have kind of group here, right? As we can see, there are some components grouped by app service environment, and we have highlights of virtual network here. It can be useful also. Then let's try to identify how your end user will interact with your system, right? There are two obvious interaction points here. It is kind of maybe admin panel. Yeah, as you can see, there are marks related to admin website. So we have kind of administrator, probably, or internal employee, which will somehow affect created orders. And we have our customers. Based on that, at this point, we also can assume that we will have different common profiles for customers. It will be useful for performance engineering, for example, customer which will abandon his actions, customer which will buy something, customer that we will just browse product list. And also we will probably have kind of user profile for internal employee or admin, right, which will be able to do something with the system and do something with the orders. Probably he will be able to change some general settings of our system. I don't know. We should target this in a more detailed way, asking questions or reading detailed specification later if it is available. But on a basic level, we have some understanding of interaction points and user profiles here. Also, there is kind of API listed here, but as I can see, it is not exposed to public. It's kind of internal API. So probably our two main interaction points here with the system will be two browsers, two clients. And let's move forward. Technical stack. As I can see, it looks familiar for me. Yeah, it's Azure architecture diagram, right? Also, if it looks unfamiliar for you, you can observe some marks. There's Azure CDN, Content Delivery Network here, Azure Active Directory, SQL, probably it looks like Microsoft SQL icon here. There are other components which are specific for Microsoft Azure, such as application insights, Microsoft performance monitoring system and tracing system. So we can assume that it will be .NET based technical stack with SQL, with NoSQL, Redis for caching purposes, blob storage for storing some images, etc. So probably it is .NET based, SQL based, with some accents of NoSQL, and there are some blobs. Also, we can observe that there are some platform as a service services here, right? Just observing the icons. So we have basic understanding of tech stack. Let's assume protocols or transport containers here. I'm not sure about exact entities which will flow through our system, but I can assume protocols here. As far as I know, Azure CDN is a service which implements RESTful approach. So probably at this part, I will interact, your application will interact with this segment through HTTP, HTTPS. The same situation appears here. So probably majority of our connections here will be performed through HTTPS transport protocol implementing RESTful approach. Right, so RESTful is pretty popular across Azure cloud services. At this point, probably, if this information is not highlighted, I will perform some googling, or maybe ask architect. Yeah, we already covered our components here, and let's try to assume some roles of our components. So as you can see in the middle of the diagram, probably some segment related to the logic, right? It represents logic of your two applications, of your two websites. There is a gateway through which browser will interact with our main logic layer. There are some data related storages. Here in the blob, we will store some images, probably, yeah. Azure Active Directory probably will perform some security restriction activities, right? So you should be able to authorize your employee or your admin to perform some general changes in your system. So this flow will be probably somehow secured, and this group probably will be also secured somehow, because we have virtual network grouping here, probably with own network security settings. So as you can see, we already have lots of useful inputs just observing this diagram. And it is a good idea to follow critical path here. Assuming that we have two interaction points, probably the first critical path for the system, for the business, will be path connecting your end user and your backend, right? So probably application will pull some data from blob, some product images, deliver them to the client through Azure Content Delivery Network, and then application will interact somehow with our main logic layer here through application gateway. Our applications probably will be somehow configurable through our admin panel and contain some settings, and also we will be able to collect some data from product catalog here and place some orders here, right? Actually, it is great that this flow is already numbered here, ordered here. So it's kind of modern solution architecture style to properly highlight such connectors, maybe such connection errors. I'll show this on the next slide. Okay, yeah, we followed critical path. Do we have any information about volumes or data sizes here? Probably not. It's point for asking the question. Also, let's try to assume, will it scale or not? You know, as my background, if I'll dig a little bit my background knowledge, probably I will assume that infrastructure will allow you to scale your application, but current implementation doesn't highlight this scaling. So probably in your initial version of this solution, it is not scalable a lot. So it is probably a good question to ask your architect here. And then I'll summarize general questions which appeared during my initial analysis. And that's it. We have already collected lots of useful inputs for testing. And let's try to look at the legend of our diagram. As you can see, here data flow is detailed by number, as ordered list. So we could assume our data flow. Customer performs some access to public website. Browser pulls static resources and product images from Azure CDN. CDN pulls product images from blob storage, and customer searches for some products. Public website pulls product catalog from product database. Page output is cached in the Azure cache for Redis. Customer creates new orders. Public website invokes orders web service. And orders web service saves or loads orders from Azure SQL database. Employee accesses the admin website in browser and authenticates through Azure Active Directory. At this point, employee is able to perform search activity for orders and invoke orders through web service. As you can see, we were generally right about the purposes of our system, about specifics of our system, right? Just observing the diagram without this legend. And as we can see, I've highlighted detailed component information here. We have app service, we have apps, Azure SQL database, API applications, application insights, which will allow you to collect performance metrics, performance statistics, triage, maybe some logs in a more efficient way. Probably your developers will perform some instrumentation of the code, which will allow you to trace some atomic transactions which will flow through your system. We have application gateway, cache for Redis, content delivery network, and Azure Active Directory, as well as blob storage. It is an example of well-built diagram with well-built and I don't know, clear legend. It will give you just lots of context, lots of inputs for testing just in a 30 minutes, or maybe in a 10 minutes in our case, right? And the next point that I would like to highlight, how to memorize complex technical information such as architecture efficiently. How to avoid situation when someone will ask you in a half year about your system, or probably will ask you to draw, at least on a basic level, some diagram on the board, and you will stuck at this point. As I have highlighted several times during my during the topic, imagination is a powerful tool, and built on that, mnemonic techniques are extremely efficient tool set for effective memorization. So it's not something mythical. It works for almost any information, even for extremely complex stuff from information technologies. You can even memorize design patterns with mnemonic techniques, or maybe some system architecture vision details, especially if you are working with some extremely complex architecture. And actually, it worked for me. Maybe it will work for you too. I'm following a couple of mnemonic techniques, maybe 3 years or maybe 5 years already. And I was surprised about efficiency of these mnemonic techniques. Definitely, it's kind of personal thing. So not each method will work for you, but maybe you will be able to find the most effective for you personally, right? If you're a skeptic, just give it a chance. Try it at least once. You know, memory champions, Guinness memory champions, are following these practices, and they are able to recover full P number, digit by digit. That's why I was kind of surprised about efficiency of these techniques and tried for myself. Here you can find a list of useful articles related to different mnemonic techniques. Majority of them will be useful for information technologies. And at the end, I would like to show you short, maybe 2 minutes video, which represents techniques that I commonly use. It's called Memory Palace. I hope that Zoom will be able to share video properly. Let's pause it just to build up some buffer here. And here we go.
Igor, I'm sorry in video.
Once again, please, can hear. Yeah.
Anyway, we can send this video to participants with a feedback form after the webinar. Igor, you're muted.
Oh, is it not working? Okay. Sorry for that. Actually, it looks like Zoom has some issues with Google Slides and with incorporated YouTube videos. You can take a look at the video afterwards. We will send you a presentation, so you will be able to observe this video. In a couple of words about this technique, you create some kind of imaginary objects related to some concepts or some ideas or some contents which you are trying to memorize. And you imagine some kind of familiar place, maybe your flat, maybe some kind of palace, and you place this object there and attach information chunks to these objects in your imagination. With proper practice, you will be able to memorize huge lists of information in just 2 minutes and quickly access these memory slots by purpose when you want to do this. So if you are skeptic, just try it. Maybe it will work for you. Also, there are lots of quick memorization techniques by the link. And yes, let's complete presentation stage here and move forward to your questions. If you have any. Yeah, I see comments about sound. Yeah, probably Zoom isn't perfect tool to use video attachments in presentations. Yeah, I'll know that. Definitely, we will send you attachment afterwards and probably record, so you will be able to click and look at it. Okay, is it only helps for QA or for another specific jobs? You know, such analysis approach helps in general anyone who tries to assess the system for the first time. It's kind of tool or checklist which will allow anyone to assess a system quickly and gather valuable inputs for understanding of the system at the first place, right? I've highlighted test coverage because our topic is mostly related to QA engineers, but it is useful in general, right? So you will probably follow such steps during initial analysis of any architectural diagram. If you're a developer or maybe business analyst, you will somehow perform these steps. So it is also useful for other specific jobs. Okay. How do you analyze solution architecture for stress testing to build a strategy? Same way, thanks. Yeah, you know, for detailed performance engineering approach, of course, I will collect much more information, but I will start with something similar, right? Of course, for effective performance engineering strategy, you will need much more insights about the system. You will need some non-functional requirements. You will try to collect these non-functional requirements, maybe playing role of business analyst partially. You know, performance engineers kind of wide specialization, right? It covers lots of topics, and probably you will ask lots of questions because proper performance engineering strategy will not cover only server or some server component. It will be applicable for maybe for several components. You will assess or I don't know, stress several components at the same time because your goal is to create realistic load for your server, right? So even if you are doing stress testing, you are usually following a realistic workload distribution model. right? For stress testing, I usually use the same workload distribution model as for other types of server-related performance tests, such as capacity, fixed load, or memory leak. So I usually build up kind of set of realistic profiles of our end users, not only 3 as I've highlighted previously, but maybe 10 or 15 with different presets, and it definitely will require more analytical job from you. Also, you will definitely need much more context about the system and technical details if you are performing some client-side performance engineering or some client-side performance analysis, or maybe you will implement both approaches for your test coverage. Yeah, but initial step will be the same. You will assess system in the same way. You will perform the same steps inside your brain. So it is always a good idea to organize this, right? And that's what we highlighted before. I hope I've answered your question. Okay, yeah, but if a diagram created with the blind spots in consequence, I won't understand correctly, so I depend my further understanding on the wrong basis. Yeah, you know, it's kind of question for proper architecture review to avoid some blind spots or maybe duplications, blind paths inside your solution architecture. And if there is no review, you will probably somehow perform your review, right? At least you will assess the system for testability for your targeted activity, right? Maybe performance engineering. And for such blind spots, you will, of course, ask questions and collaborate with diagram creator. It's kind of live process, right? So the purpose of initial analysis is to give you, in a short time, significant amount of information and understanding of the system. Something to start with, right? Of course, it's kind of a starting point for your process, especially if you are performing complex activities such as complex performance engineering approach from scratch, right? And such blind spots probably will be covered by you, by your solution architect, by architecture reviewers, and fixed. It's kind of architectural bug, right? Architectural issue, which should be fixed, of course. But, you know, from real experience, there was such situation in the past when architecture was changed significantly, maybe in 3 months after the start of the project. Life is a life, you know. There are lots of things which can happen. Hope I was able to answer you. Thank you for the question. Anything else? Okay. Oh, it looks like we were able to fit our time slot, which is always great. So thanks for your time. Stay safe, stay healthy, and stay positive. And always try something new. Have a great day or evening. See you.